Let's suppose that you have some sort of future savings goal. You have a target amount that you would like to have in your savings account. Well, how does that translate into today? What is the present value of that investment? That means, how much do I need to deposit into a compound interest account today so that over time it will grow to a specific goal? In section 8.4.2, we'll study the compound interest present value formula. To obtain this formula, we're just going to rearrange our future value formula. Recall that the future value for a compound interest investment is P times 1 plus R over N exponent NT. A, of course, is the future value, and another word for present value is principal. How much do I need to deposit today? So to obtain the present value formula, I just need to solve for the principal. To do this, we can divide both sides of this equation by the factor 1 plus R over N exponent NT. So what I do to one side, I have to do to the other side of the equation. So on the right side, that entire factor cancels, and that isolates P. So our formula becomes A over 1 plus R over N exponent NT equals P. Or if I switch it around so that P is on the left, we have our present value formula. Remember, present value simply means how much do I need to deposit into a compound interest account today in the present so that it will grow to some future value, some amount or target that we have in mind. The present value formula and the future value formula are essentially the same. They have just been rearranged. Let's try an example. Suppose that you owe $1,200 to a loan officer in 2 years. So you've got a debt, you know you're going to have to pay it in 2 years. If a bank offers a monthly compounding savings account with 3.1% interest, how much must you deposit now in order to have $1,200 in the account at the end of 2 years? So the idea here is very smart. You know you have this debt coming due in 2 years. Instead of paying all $1,200, you're going to take what you have now, a specific amount, deposit it at compound interest, and let it grow to $1,200 so that you can cover part of your debt with interest. So we need to know what's the present value of this loan. So we've got a future value of $1,200. The time that we're dealing with here is 2 years. The rate of interest available is 3.1%. And we want to know, what is our present value? How much do we need to deposit now? Another thing that's important is our bank offers monthly compounding. So that means N is 12. So let's plug everything into our formula. So the future value is $1,200. The rate is 0.031. Remember, we moved the decimal 2 places to the left. N is 12 in both the denominator and the exponent, and the time or the term of our loan is 2 years. So we can type this into the calculator exactly as it appears. The fraction bar we will enter as divided by. Make sure we use our parentheses there in the bottom. Close parentheses before entering the exponent key, and press enter. So $1,127.95. $1,127.95. So to cover our $1,200 loan, we're going to deposit $1,127.95 in an account. We're going to leave it alone for 2 years at this monthly 3.1% compounding. And then at the end of the 2 years, when I go to collect the amount in the account, it will have grown to $1,200. So notice the $1,200 future value minus what we deposited, $1127.95, means that we have earned $72.05 in interest. Now, that works only if you have that present value available to deposit, but it's a great strategy to save a little bit of money on a debt.